Thanks for joining me on another edition of Fact Finders. Today I'm going to look at compression. Why is compression necessary? What's the best way to handle compression? So I'm going to go try to find someone who can fill me in on how to do compression the right way. All right, so I've found my expert that's going to help us address this issue of how to do compression and what it's worth and how it affects performance, and that expert is Art Licht. Art, thank you very much for joining me today.
Oh, glad to be here, Eric.
Great. Now, what do you do at Oracle?
So I work in the solution centers. I am chief systems architect, and we take a look at the products that come out of engineering and, bring them together, software, hardware, coming together to solve customer business problems.
Okay, so you're not just dealing with one product or one storage system or whatever. You actually, depending on the customer problem, can pull from all the different components that Oracle has to build a solution. Is that right?
That's right. We bring things together here.
So we're talking about compression today, and I was just wondering what types of compression are available on the marketplace today?
Well, there's about three types. So the first is storage array-based compression, where the compression would be running in the storage system. There's a handful of compression appliances that are out in the market that sit between the servers and the storage and would compress the data. And lastly, there's compression technologies running in the server. For example, database compression.
So why do people compress their data?
Well, historically, compression was used as a way to save money. It was a space savings technology. You would compress your data so it would take less space. So in effect, you can buy less storage or take the savings you get and use it elsewhere.
Well, I'm still trying to get my hands around this whole compression thing, so is there a way that we could take a look at what's really going on inside the database?
There is. I've actually built a little demo system where I have a couple databases, some running with compression and some running without compression, and we can take a look at the differences.
Okay, great. Well, let's take a look. All right, so Art, we're going to take a look at this demo. Tell us what we're looking at.
So what I have here is two identical databases from a content point of view. They contain retail data in a handful of different tables. The database on the left has no compression, so I haven't compressed anything. The database on the right, I've applied various different database compression techniques, compression for OLTP and hybrid columnar compression.
So we're using the exact same systems, exact same storage, everything's the same. The only thing that's different is one database, the tables are compressed, and the other one they're not. And so when we run these, what do we come up with?
So on the left, I've run a query where I've asked the database to find all the cash register receipts, count them up, and group them by state, and then print them out.
Okay.
And you can see it just did that, and it took 7 minutes.
So what was going on in the system while the queries were running?
So according to the database AWR report, the system was waiting on I/O. So the CPUs were doing practically nothing while the database was waiting on I/O.
So the CPUs were sitting there idle and just starving for information, basically.
Exactly.
Okay. Now, what did that look like when we look at the compressed system?
So I then ran the same query on the hybrid columnar compressed database, and it returned the same results in 1 minute and 9 seconds. So approximately 7 times faster.
That's amazing.
And then, just to see what the database was doing then, I went back and looked at the AWR report, and the first thing I noticed was the database was no longer waiting on I/O. The load average is down from above 9 to below 1. So it's kind of like we've opened up the pipes. And the queries were able to run a lot faster.
Wow, that's dramatic. So this definitely runs faster. What about the size of these systems, the size of the tables? Is that any different?
It is, and I can actually show you that live. So if we look at the database, you can see uncompressed, we have tables that range from 661 gig, 37 and 35. And on the compressed database, those same tables, if you look at the retail transaction table, which is what we've been talking about, it's 24 gig. And that's because I applied OLTP compression to it. So that table is easily changeable, updatable. I then recreated that data, and I stored it in a table called My Data, and I've applied hybrid columnar compression to that table, and the 35 gig is now 1 gig.
Wow. So all that data is the same, but we've gone from 35 gig down to 1 gig?
That's correct. And the query on that 1 gig is running 7 times faster than the query on the 35 gig.
Wow. So not only is it faster, but we've saved dramatically on space. We've done both at the same time. Exactly what we were looking for.
That's right.
So what type of compression did we use over here to get down to 1 gig?
So this is hybrid columnar compression. The actual database command is compress for query high.
Okay, Art, what would this look like in a real world environment?
Picture a database or a table that looked like this, and we're going to use partitioning to partition the tables by date. So over in the 2012-2011 era, we would be applying OLTP compression, and that's because that data is changing. But the bulk of the data in this database is historical data, and when we partitioned it by date, that enabled us to apply different compression to the various different table spaces or partitions, and in this case we would apply HCC, which is available in Exadata, a ZFS storage appliance, or an Axion system, to that data.
You mentioned Exadata. How does Exadata fit into this?
So Exadata was the original product that had hybrid columnar compression in it, and where this ties together is you run your database inside of an Exadata or a supercluster machine for that matter, and you could back it up via RMAN to a ZFS storage appliance. And because the ZFS storage appliance, just like the one we're running here today, understands HCC data, we're able to create snapshots and clones from that backup set and present virtual copies of the database out for development and test environments without using a duplicate amount of space.
So this looks like a great way to get that data, get a backup copy of that data, and then use it for other things outside of your actual application that's running.
Exactly. And the nice thing about this is I can run all the dev and test environments I want, and they have no impact on production.
Does the backup go faster because the data is compressed?
The backup does go faster because there's less data to move. So if we got 30% less data, you would expect your backup to go 3 times faster.
Wow. Well, this is really great. Great use of all the technology, really, that we can bring to bear to this. So thank you very much for showing us this.
Oh, you're welcome.
All right, well, Art showed us a very dramatic example of how to get a lot more capacity and more performance at the same time by using hybrid columnar compression, which is available, of course, on Oracle storage systems as well as Oracle Exadata Machine. If you want to learn more, you can go to oracle.com and download a white paper on the subject, or ask your sales rep. They'll probably be able to set up an evaluation to see if hybrid columnar compression can help you. Thanks for watching, and join me next time on FactFinders.